Hi everyone, and welcome back to this tutorial series on the EKOS astrophotography toolset that is within the K-Stars Planetarium software. In this episode, and the next one, I'll be showing you the options in the alignment module. I'll start in this video by helping you set up EKOS for plate solving. Then in the next video, I'll be showing you the Polar Align Assistant and the go-to solve operations. You'll find the alignment module here in the top menu of EKOS, underneath the icon with the target circles. Now, sometimes this panel moves around a little bit. Sometimes it's here in the middle, sometimes you can find it a bit more over to the right. It depends on the order in which your equipment connects to the INDI server. But it's always in the same panel with the target icon on it. And once I select it, we are now in the alignment panel. Alignment in EKOS has pretty much everything to do with plate solving. And before you can perform any of the functions in the alignment module, you'll need to make sure that you have plate solving set up correctly. Fortunately, this has become a lot easier in recent versions of EKOS. Since the last couple of versions, EKOS gives you pretty much one option by default, and you will need to dig further into the menus for more advanced setups. And by that time, you are probably more familiar with all the options that are available. You can see here in the lower left corner that I currently have the local Stellar solver selected. This is the new proprietary plate solver from EKOS, and you can find the rest of the options under the Options button here in the lower right corner. The first thing you'll need to check is if you have the right index files installed. You can do so by navigating towards the Index File tab. Here, EKOS shows you the location where your index files are stored. If you have already downloaded your index files but to a different location, or you need to download new files and you want to store them in a different location, you can click the plus button right next to this path and you can add a new location for EKOS to index. It might be good to know that you can use more than one location at the same time. And if you've installed those images in a different location and you want to move them over, then after you've added the new location, you can just copy the old files to the new location. Now, we'll come back to the rest of this information later. Let's first take a look at the lists with index files. When you, for example, look at the very first entry here, beneath the 2MAS catalog list, you see the name of this file, 4219.fits. And in the leftmost column, you'll see the field of view that's associated with that index file. In this case, 1400 to 2000 arc minutes. The one underneath, for example, has a slightly smaller field of view, between 1000 and 1400 arc minutes. And the one underneath that, between 680 and 1000 arc minutes. And so pretty much every field of view has its own index files associated with it. In between the index file name and the field of view, you can find a check mark and an icon. The check mark indicates if you have downloaded this file, and if that is available for EKOS to use. And the icon shows you if you should have downloaded this file. When you look up here, you can see the explanation for those three icons. So the shield with the green checkmark indicates that the file is required by EKOS to plate solve images taken with your equipment. The shield with the orange warning sign, these are the recommended files for you to download. And then there are the shields with the red checkmark, the red cross. That shows you the files which are optional for you to download. So remember that when you are switching between different telescopes or different cameras, you'll need different index files for each of those setups. Now, if you look a little bit below the index files location, you can see the field of view that's associated with your current CCD or CMOS or DSLR camera. So you can manually check if you have those images. Now you must select all the image files with a green check mark or an orange warning sign. Just click the check marks in front of the file name. And once you do, you'll see that EKOS will download the set of index files and put them into the specified location. If you have accidentally clicked one that you didn't want to download, you can cancel it by pressing the red X button on this side here. Now that you've downloaded all the proper index files, I wanted to quickly show you a couple more options. First, we can go to the Stellar Solver Options tab, up here in the configuration panel. And you'll find another important setting, especially if you are planning on using a different plate solver than the built-in Stellar Solver. Again, the internal Stellar Solver has been working great for me ever since it was introduced a couple of months ago. but you can still choose to use a different solver. For example, a locally installed version of Astrometry or the STAP application. Or you can even send your images to the online astrometry.net solver. If you choose to use, for instance, the STAP application, you can then select it over here and go to the External and Online Programs tab. And here you can set up the required configurations for external solvers. For instance, the location of your STAP binary file. But let me put it back to the internal solver since it's been working good for me. So while we're here, I quickly wanted to show you some more settings that might not be that important to check right now, since they are set up correctly by default. But it's good for you to know that these features have options associated with them and that this is where you can find them. I'm talking about these options here in the Scale and Position tab in the same configuration window. The features I'm talking about are the Use Position checkmark. This feature basically sends the coordinates of your mount, or at least the position that EKOS thinks that your telescope is looking at, and it will send those coordinates to the Stellar solver. And that will narrow down the places where the solver will look for a solution. This will speed up the results of your plate solving. And the next check mark is the auto update feature. This auto update feature basically makes sure that these coordinates get updated every time that your mount slews to a different position. And then there's the radius field. And this is the radius that the Stellar solver is going to look for solutions around the coordinates that it thinks that your mount is pointing towards. Right now, it will look in a radius of 30 degrees for the solution, and this also really helps to increase the speed with which the Stellar solver comes up with a solution for your plate solving. So sometimes when you've done something wrong and you can't get a solution, perhaps your mount is looking at a completely different place in the sky. You can then increase this radius, and then it will take a bit longer, but perhaps EKOS will find a solution anyway. So make sure to apply the setting, and then we will check whether it worked or not. So since this video is about setting up plate solving, I will explain all these other settings in the next video. So the only thing I want to do right now is I want to see if plate solving is working. Let me just make sure that I've selected the right camera, which in this case is my CCD simulator. And all I have to do now is look in K-stars to find a nice target. Let's see if I can find a nice target. Well, go to capture and solve. All right. So as you can see, EKOS has solved the image and basically tells me that the telescope is really pointing to M34. I didn't expect anything else because this basically is a simulator, and the simulator always gets it right unless I program it to get it wrong. So obviously in real life you will see perhaps a couple more iterations are required, but it should be able, if you followed these steps and you downloaded the right images, EKOS should be able to solve your images as well. So in the next video I'll be showing you all the other settings in the Align module, and I will also be showing you a real-world scenario where you can see that the solver will need a couple of iterations to find the proper target. If you're interested in that, stick around and keep an eye on the channel. But for now, this basically was setting up EKOS to use plate solving. So I hope this video was useful to you. If it was, please consider giving it a thumbs up. Also, I'm really excited about all these amazing reactions I've been getting on this first video I released. Thank you all so much for that. If you have any questions about the things I've shown to you in this video, feel free to post them in the comments and I'll be sure to reply. And if you have any other EKOS topics you want me to cover, let me know as well. I first want to finish this 101 series, but I'm keeping a list of the other topics, so keep them coming. And for now, take care and see you later.